The influenza virus is common in our everyday lives, but it can be deadly, especially for the young and old. It is difficult to treat the virus because it changes so quickly, making it arduous to develop vaccines in time. Sometimes the flu breaks out into pandemics, a recent example being the H1N1 and H1N2 flu pandemics. With globalization and better transportation comes a risk. It becomes easier to spread. With all this in mind, what if we could predict what new and mutated flu viruses are going to be? Well, that's what we are doing. Maybe not for the flu of tomorrow, but to predict the flu in say 5, 10, or even 20 years. We plan on using bioinformatics and phylogenetics to model the evolution of viruses, specifically influenza A, and predict how and what they might mutate into in the future. Our project is targeted towards research and education. Researchers will be able to see possible genetic outcomes of the virus over a number of generations, for usages such as phylogenetic mapping and developing vaccines.
It can also be used for teaching students about the evolution of viruses and what they look like. Currently, researchers have done this in the lab with live viruses by changing the environment to see how they evolve. This has become controversial because if they somehow get out,
Well, let's just say, wouldn't it be fun?
it would be far safer to model or project these viruses' evolution in a simulated environment.
We have devised two ways to approach this problem. The first is by using genetic algorithms to mutate the initial nucleotide sequences based off of the average known mutation rates. This would continue for n number of iterations while also assessing the fitness level of each child sequence and determining if it should continue. In the end, we would have a database with possible outcomes bound by the simulation.
Or we can look at the problem the opposite way. Rather than mutating the virus directly, we can look at how the human body defends against viruses and simulate how a virus might circumvent the immune system.
We call it viral comp, modeling our lives by modeling the future.